Hi everyone, this is your math guru. In this video, I'm going to show you how to prove the following trigonometric equations by applying the necessary trigonometric identities. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. In the first example, we had to prove without the use of a calculator that if sine 28 degrees is equal to A and cos 32 degrees equals to B, then B root 1 minus A squared minus A root 1 minus B squared is equal to 1 over 2. We've been given the equation to use, so substituting the value, we have A to be equal to sine 28 degrees and B equals cos 32 degrees. Putting that back in, I have B, which is cos 32. I have cos 32 degrees, roots of, I'm going to be proving my left-hand side. I have 1 minus A, which is sine 28 degrees, all squared, minus A, I change that to sine 28 degrees, root of 1 minus B cos 32 all squared. Remember, I'm proving my left-hand side. If I simplify, I have that as cos 32 degrees square root of 1 minus sine squared 28 degrees minus sine 28 degrees root of 1 minus cos squared 32 degrees. Note that from trig identities, cos squared theta plus sine squared theta is equal to 1. Therefore, I can either have cos squared theta equals to 1 minus sine squared theta, or I have sine squared theta equals 1 minus cos squared theta. Therefore, I'm going to be replacing the content under my root sign accordingly, where in each case, my theta is either 28 degrees or 32 degrees. So I have that as cos 32 degrees square root of cos squared 28 degrees minus sine 28 degrees square root of sine squared 32 degrees. If I take out my root sign, I'm left with cos 32 degrees multiplying cos 28 degrees minus sine 28 degrees multiplying sine 32 degrees. From your trig identities and compound angles, I have cos A plus B to be equal to cos A cos B minus sine A sine B. In this case, my cos A or A will be 32 as shown, and my B will be 28 degrees. So applying the rule, I have that to be cos 32 degrees plus 28 degrees, and that's equal to cos 32 plus 28, 60 degrees, and using my special angles, I have that to be 1 over 2. Therefore, my right-hand side is equal to my left-hand side. Let's look at the second example. In my second example, I have given cos x over tan x equals 8 over 3. Show that the above equation can be written as 3 sine squared x plus 8 sine squared, or 8 plus 8 sine x minus 3 equals to 0. I've been given, starting from my cos x over tan x is equal to 8 over 3. Note that the trig identity tan theta is the same as sine theta over cos theta. So therefore, I'm going to be replacing my tan theta by sine theta, or my tan x by sine x over cos x. I have cos x divided by sine x over cos x. That's equal to 8 over 3. If I change that to multiplication sign, I'm going to flip my right-hand side. So I have cos x times cos x all over sine x equals 8 over 3. I have cos squared x over sine x equals 8 over 3. If I cross multiply, I'm going to have 3 cos squared x equals 8 sine x. From our trig identities, I have cos squared theta plus sine squared theta equals to 1. I'm making my cos squared as subject of formula. I have cos squared theta equals 1 minus sine squared theta. In this case, my theta is my x. So therefore, this equation becomes 3 multiplying 1 minus sine squared x equals 8 sine x. If I expand the bracket, I have 3 minus 3 sine squared x equals 8 sine x. Moving all the terms to one side, I have 0 equals my minus 3 sine squared x becomes positive 3 sine squared x plus my 8 sine x. My plus 3 on my left becomes minus 3, which is the same equation I have as 3 sine squared x plus 8 sine x minus 3 equals to 0. Is the same thing I have here. 0 equals 3 sine squared x plus 8 sine x minus 3. Thanks for watching. Bye.